The Center for Educational Media and the College of Education at Middle Tennessee State University are proud to offer professional development to K-12 educators in Tennessee through our online video library. These videos are aligned with standards set by the Tennessee Department of Education. For more professional development videos, check out our website at cem.mtsu.edu.
Our first speakers today are Tammy Jones and Mary Martin. Sorry. There you go. You'll want to take your vowels. Tammy and Mary are going to make a really interesting presentation. Not that I'm trying to build up anything, and
You're warming up the crowd.
there we go. Really interesting presentation that relates to, believe it or not, sensory science. Even this is going to be a math and statistical discussion, but this is the part of the foundation of what we call sensory science. And sensory science is our perception of in particular, foods. When we eat or smell perfume or eat food or whatever the case, it's our senses that we're stimulating when we look at this and decide whether we want to put this stuff on or eat it, right? And we can't just say, well, that looks great, let's go with it. There is actually some validity behind our saying that this is actually what I'm smelling or tasting. That extends beyond just, it looks good, or it feels right. So, I'm going to turn it over to my experts. This is going to be fun. I'm looking forward to the presentation, and thank you both for being here.
Sure. I don't think we need this.
No, we have our lavaliers.
Yes,
So we're good.
We'll let you have that. So, can you all hear us? Is it coming through the, yeah, I think so. Okay, well, I'm Mary Martin, as Tony said, and this is Tammy Jones. I'm a professor of mathematics in the math department. I got my doctorate degree at University of North Carolina, Chapel Hill, and loved math before, loved math during, loved math since. I'm just a math lover. The statistics that we're going to talk about today are going to try and contextualize some of this math so that you can see where it was done in the real world and see some of the history. So the neat thing about mathematics, or maybe it's the terrifying thing about mathematics, is that it has been around a long time, and some of the math you're doing today comes from the 1700s or 1800s, some of what we're talking about. So people have been doing it a long time. That makes it comfortable. It's not suddenly technology that's blindsiding you.
And I'm Tammy Jones. I was a classroom teacher for 30 plus years. Went to Peabody, have a STEM background. My mom was a nurse back in the day when you manually calculated how much medicine to give you so she didn't kill you. I grew up with sterilized syringes back in the day. I knew cubic centimeters and milliliters. My father was a draftsman engineer, so I have seen him walk off a 3, 4, 5 footer, which surveyors came in later, and his was probably more exact than theirs were. So I grew up looking at the world through the eyes of math and science. So I majored in math and science at Peabody back in the day when you got your education early childhood through 12. The Kennedy Center was sitting over there, so everybody had 18 hours of special ed. So I have a unique perspective. I'm as comfortable in a kindergarten classroom as I am on a college campus. I do have a master's in math as well. My specialization for science was really chemistry and biology. So we're hoping today to bring together some topics and some ideas to help you understand, as Dr. Johnston said, some of the foundations for where science goes with STEM education. And we want to start with literacy, because in any classroom, the first stumbling block for most students is literacy and communication. And when you're dealing with applications, when I was teaching the Math for Technology, the applied mathematics strand, our textbooks from Cord did not have problems typical of a math book. They were all word problems. And that was the first barrier to students. And there's some interesting research that, and by the way, there is an email sheet going around. Don't have to sign up unless you want to, but if you want to, I will send you all the materials from today, send you a link to a Dropbox with everything that we're doing in there so you can have it, use it with your classroom if you want it. So Miners and Pescapella talked about Literacy being able to take those symbols, being able to take whatever you're looking at and actually synthesize it and communicate about it. And is that not what we're about, whether we're elementary, whether we're nutrition, whether we are science, even with CDC? Is that not one of our issues that we have? So with that in mind.
And one of the things I'd like to add is mathematics is a communication form. If someone tells you 6 without any context and without any justification, that's pretty meaningless. So all the symbols you do in mathematics are justification of how logically you defend the answer 6 and what that 6 is supposed to mean to you later. So it's all about communicating.
So NCTM is the National Council for Teachers of Mathematics. They've been around for years. They were the first ones to actually promote national standards as such before Common Core, which is now kind of a dirty word everywhere, but if you're teaching in Tennessee, you're doing Common Core. If you're teaching in Texas, who doesn't do Common Core? You're doing Common Core. I work a lot in Texas. They define mathematical literacy a little bit differently, and I want you to just take a minute and read that to yourself. There aren't very many of you that are math teachers in here today. I kind of did a poll as you came in. We have nutrition, we have CDC, we have several different areas of science, we have elementary. We don't have a whole lot of just pure math. But mathematics is the queen of the sciences. It is the tool of the sciences. And one of the first struggles in school working with STEM education is that the math that is needed to really study the rich science is not there in time for where it usually occurs in curricula, unfortunately. So how many of you have an appreciation for the value and the beauty of mathematics? And it will not offend me if you say no, because I deal my life with making math accessible to people and helping them understand that it's not okay to say I can't do math, because we don't say I can't do English or I can't do social studies. Everybody can do math if it's made accessible to you. And mathematics is beautiful, okay? It is our world.
There is a journalist who interviews professional experts of all different fields, artists, sculptors, biologists, chemists, mathematicians, musicians, everything. And she has a quote that you can look up online. It says that of all the people she talks to, the group of people that use the word beauty and appreciation the most are the mathematicians. They have the most respect for elegance, beauty, and they understand it and look for it. So beauty and mathematical literacy all go together, and it's very important. You really leave something out if you don't convey that to your students.
Now, how many of you in your classrooms deal with, let me see if is going to read, deal with quantities? Does anybody in here deal with any kind of quantities? If you're dealing with quantities, you're dealing with mathematics, right? So literacy. Now, mathematical literacy in conversations, this is just a graphic that I use a lot with teachers to kind of bring home the point. And I think, Mary, today we're going to try to connect these, aren't we? Yep. Where we try to bring together mathematics, literacy, and again, as Mary said, talk about that communication and conversations.
So you're going to be functioning on a lot of levels. You're going to be learning some math that you will need to work on again a little bit later, because you don't visit math once, you revisit it. We're thinking about some literature, we're thinking about communication, we're thinking about pedagogy and teaching styles, and you're going to plug into all those different levels and make notes about what you want to revisit. We're doing more today in 2 hours than you could do in 2 months of classroom teaching, in terms of pulling it all out and getting it together and spreading it out through the classroom. That's okay. That's what today is about. Today is about getting this developed.
And you get to play the role of the student. Too often as teachers, we sometimes forget what it's like to sit in the seat where our students sit. So this will give some of you the opportunity to kind of experience content as a student would, which is always a valuable thing for teachers to experience. So I am a firm believer, and have been for my 40 plus years in education, in using trade books. Literature is a way to connect with students. I don't know how many times I've been told, well, I don't do math, I do English. I like to read. Well, good, I will give you a trade book and then we'll talk about some math, okay? So what is a trade book? Pretty much anything that has words in it that you can read. We're gonna talk about some things today. I actually gave our elementary teacher the one to look at for elementary, but I work with trade books all the time. So this is just a whole slew of things you can do with trade books that your library probably already has. If not, librarians spend money on STEM. If you go to your librarian and say, I want to buy some books for science or math, they will ask you which ones and how many. I've never walked in a library that they turned me down for buying math and science books. So we're going to take a trip today. So Mary, you want to talk about where we're going to go?
Sure. When you start a math topic and you're teaching a math topic or you're learning a math topic, you want to start out getting an overview of what you're doing, why you're doing it, start digging into the introductory material, then you want to go back and do an example. So if you're a scientist, you call it an experimentation or an exploration. If you're a mathematician, you may call it an example, a practice problem. So you want to go between, you want to bounce back and forth between the concrete and the theoretical. You want to do a little bit of thinking, a few definitions, practice them in an example. Do a little bit more thinking, put a few more ideas on, practice it in an experiment. In math, and Tammy likes to say this, so I'm going to let her say it. In mathematics, we do have a laboratory, and that laboratory has a particular item in it, and you like to say,
I'm sorry.
you like to say that the calculator is?
Oh, the calculator is a tool of investigation, which when strategically integrated at the point of instruction, becomes a valuable tool of investigation.
So we investigate in a laboratory setting in mathematics also. We just use the calculator. Now that is a different perspective than it was 15 years ago or 20 years ago, because they didn't have calculators that were robust as they are now, or even go back further, they didn't have any at all. So investigation in a lab for mathematics is paper and pencil, pre-calculator. It's a whole lot easier to investigate now. And then you consolidate your answers, figure out what you know, what you don't know, and every one of these transitions can be integrated or promoted through using ideas that are common sense or ideas that you've introduced in a trade book. So we have a particular mathematical trade book that we're going to bring forward that is a piece of literature written about science, piece of popular fiction or nonfiction written about science that will inspire and help you understand how these loops went around in statistics.
And this is cyclical, okay? How many of you could plug your content area, those of you that are teachers, into that same cycle? I mean, that's pretty good, just basic instructional strategy there. So again, I tell teachers, especially elementary teachers, when they perceive themselves in the primary years as being reading teachers, those same strategies that we use are the same strategies that we're using in mathematics to make math accessible to all students. So why use trade books? You use trade books for three main reasons. It can differentiate. RTI, we could have a whole thing on that. Differentiation is huge. If you're a classroom teacher, you're tier one, the buck stops with you. You're the one that's differentiating to make it accessible to most of your students. I'm not going to get on the soapbox there. Cross-curricular connections. We're going to use a trade book today in which there is absolutely no math, but we're going to use it for math. You can read this book and there's not a stitch of math in it anywhere. And it engages students. Because again, you have students in your classroom that are sitting there going, this is math, I like to read. Great, here's a book, go read this chapter, come back and you're going to report out and talk about it the next day.
And you were saying that Tony was saying that he liked to read, but he liked math when he got to the point where he really knew what it was useful for. The books tell you what it's useful for. They tell you how it was developed. They tell you the history of the ideas so that it provides the context for the student as they read it without you having to tell it to them word by word by word. And if you're a math student that likes to know what it's good for, get a book and read it in conjunction with other things that you're doing.
And even if I'm in high school and I'm teaching biology, I will bring in one of the Cindy, I've just lost her last name, books about the polar bear cubs or about the tigers, and use that to talk about data and numbers and fractions and calendar and feeding and all that stuff that we do with animals. So just because a trade book may look like a children's book, it doesn't mean that it even has a place in a secondary classroom, because sometimes that level is what makes it accessible to your students. Now, anytime you are reading, and this is another big thing of which I'm a proponent, we don't just read to read. That would be sometimes a waste of time. So you have 3 opportunities when using a trade book. The first one is before you read, which means, guess what? As a teacher, you read what you're having your students read before they read it. So you know it's coming. So as you are getting ready to read, you are prompting students, you're having them predict, you're having them think about. If you're in elementary, this can even be like circle time or center time, small group time. You are then having them be a mathematician, be a scientist, be a biologist, be a historian, be a farmer, okay? Whatever the niche is, be a chef. Then you always have to have opportunities for authentic writing. I am a math person standing in front of you telling you I've used the mathematician's notebook for decades. We cannot put writing off on English teachers only. We all have to own authentic writing opportunities in our content area.
And the mathematician's notebook takes the place of the laboratory journal for the scientist. Or, in my case, my students have seen me use my version of teaching mathematician's notebook, where I keep the notes of what you asked me to do, what I plan to do, what problems I'm going to do, what things happened in class, what promises I made to you, and you keep that up so that and write it down so that you can keep track of what's going on, and you improve your writing, and you make observations.
So if you get a time during the break or want to peruse, you'll see that everything that I do in here, there's always those 3 opportunities. And of course, now I can't find a page that has there, with suggestions. So anytime you're going to use a trade book at whatever level, you need to make sure that you are providing and thinking and planning for those three things. So to help you along the way, and this is one of the things that will be in the Dropbox link, if you want to give me your email, and I won't do it this weekend because we're leaving here to go do 2 more sessions somewhere else tomorrow and Saturday. So we've got a busy weekend, but I'll be back in the office Monday, and I will put together the email list, and I will shoot you a Dropbox link. I have an infographic on 10 tips for effective questioning, which was kind of embedded in our last book series that I did on integrating logical reasoning and developing understanding with all disciplines. And then the infographic for the 7 opportunities for authentic writing that you can print out, use in your classroom as you see fit. So our book.
The book is The Lady Tasting Tea. There's an interesting story behind this. The fact that I know about this book, it's written by David Salzberg. He is a mathematician who worked for Xerox and a statistician, and he got interested in the history of statistics. So he went through and wrote a book about all the major players in the world of statistics who developed the different tests. One of the big ones in food science and fermentation is the t-test. And he talks about that and the development of the earliest form of statistics. So I will give you a brief note of where this book starts, and then we're going to look through the blend space to get more information. The book starts in England in a tea shop where a lady is complaining to the waiter that he poured her tea incorrectly, only in England, right? She said, "Sir, you put the milk in the cup first instead of the tea. I want the tea in the cup first and then the milk on top. That's the correct way to pour it." And the waiter's looking kind of, and her colleagues that were sitting at the table, they're going, "How can you tell that?" And she said, "You can taste the difference. It's a world of difference." So David Salzberg wrote this book. I was listening to the story on the radio, and for the 2000th anniversary of the students' tea test, they decided to figure out what she was tasting. And it turns out that if you put the milk in the cup first, the hot tea curdles the milk. That is, it breaks some of the protein bonds. If you put the tea in the cup first, the cup cools the hot tea, and then when you pour the milk on top, those protein bonds don't get broken because they're temperature dependent. And she was able to taste those broken protein bonds, which was a genetic abnormality that's not common. So if she hadn't been sitting there complaining when Fisher was listening, they never would have developed this branch of statistics, because she just in the right place at the right time to be able to taste these broken protein bonds.
So there's your sensory, right there, okay? All because of. So one of the things that Mary and I alluded to that we want to do is not just give you some math, but also try to give you some training as far as professional development and strategies you can take back. Are any of you familiar with blend space? Just one, yay. So you're going to have a new resource. On the back of your cool handout, there is a link for the test teach. I think the www.blendspace.com still works. If not, there is a bit.ly that will take you to this one space that I created for a session that Mary and I did a couple of years, or gosh, 3 or 4 years ago now. Blend Space, I like to describe it as a safe playground. It's a cool sandbox in which you can put your students, because you can go in as a teacher and you can create your own class. I do that a lot here with the classes that I teach at MTSU. I create a Blend Space area for them. They can go in, I can create presentations where they already have the resources they need. They can go in and create a blend space as a presentation, pulling in resources. So it's a really cool teaching tool. And as I said, it is a safe playground because you place there as the teacher what you want them to do. And if you don't want them to go out to a link, they don't have to go out to a link. Everything stays in that safe playground.
So it keeps them from roaming all over the web is the point.
And there's a ton of blend space things that have already been developed out there. Some are good, some are not so good. It just kind of depends. So when you play it, and I'm not going to go through this whole thing, you can see I've got some notes up here for students and I've got some things for them to do. I can actually go out. If you are a math or a science teacher, you need to know one of the oldest websites in existence. It is called the Mac Tutor, MACTUTOR. You got to be careful because Mac books will open up everything when you go to Mac Tutor. You'll get tutors for Mac products. But it's MACTUTOR. It is actually the original St. Andrews, not the one we're getting ready to go to this afternoon, but it's actually Scotland, St. Andrews in Scotland. They have had the Mac Tutor Science for Math and Science up almost since the inception of the internet. So anything you want to know about a scientist or a mathematician, you can find it there. They have full biographies by topic, by place of birth. So just to show you, that was the one for Sir Fisher.
Question.
Well, you know what? We're on the internet. I always just Google Mac Tutor. That's what I do. See, if you Google Mac Tutor, then there it is. Mac Tutor History of Math. It's a weird URL. It's actually history.ncs St. Andrews.
UK because it's England.
Yeah, so I just do Mac Tutor, Google it, and it works really well.
That's okay.
Okay.
Ronald Fisher is the mathematician that opens the book. His story opens the book in The Lady Who Tasted Tea.
So here's a bit of a prompt for the setup. Okay, did y'all turn sound off? Sound booth? Sound booth.
We gathered at the table as a friendly group of colleagues. The gathering had been progressing in a lively fashion, and the teacups were being refreshed, when Lady Ottoline abruptly stopped the server and pointed out with disdain that he had poured milk first and then tea, rather than abiding by her widely known preference for tea first and then milk. Sidelong glances were exchanged by numerous members of our assembled group as they questioned what difference could it possibly make whether milk or tea were poured first in the cup. It made, according to Lady Ottoline, all the difference, a difference she could easily taste. It was at this point that I, as a scientist and amateur detective, decided to step in and proposed a little experiment. Safely away from Lady Ottoline's line of vision, 8 cups of tea were prepared. 4 cups with tea poured first, and 4 with milk poured first, always in equal proportions. Happily, Lady Ottoline sampled each of the 8 cups and provided the crowd with her judgment of tea or milk first. Remarkably, Lady Ottoline identified 8 out of 8 correctly. Could such a feat be accomplished by sheer guesswork? Now, as I mentioned, I'm a scientist above all. As such, I left this little party with more than just some favors. Indeed, I took with me much food for thought. Try my experiment yourself. Consider all the possible results. In what order should your cups be presented? How many cups must be correctly identified to conclude that your subject can truly tell the difference? You will undoubtedly come away with a greater understanding of inferential statistics.
Now, for the math that's there, some of those questions you actually could prompt in middle school math these days, because 6th grade has a huge bulk of rather sophisticated statistics. And then when they move into high school, there's a little in Algebra 1 with the new standards, some of the Algebra 2 has been pulled out. But a lot of this gets into what would be more of a stat course in high school. So again, there's that rub of the statistics level being at discourse with where what you might be teaching otherwise in class could be. It doesn't mean you don't use it. It just means you use it at the level at which it is appropriate for where you are. You don't ditch something because you can't go all the way to the end. There's more to come. So the rest of the story will come for students later as they progress through their journey. So this lady right here, who is Stella Kunluf, she has since passed away. She came in to work at Guinness after working in several different places, and she had the chance. She was a statistician. She was involved when there were rations. Rations involve limiting supplies, right? That means there's numbers. There's statistics, because they have to figure out how many people there are that are using sugar and how much everybody can have. In her case, she worked a lot with the bacon rations. So she was offered a job 1 or 2 places, and one of the places was Guinness, because Pearson was leaving, another famous statistician. So she went to Guinness. And her first job was just kind of to get a feel of the place. She started noticing that the number of barrels that was being rejected was statistically abnormally low. So she went out to visit what the situation looked like. We can credit her with bias. Bias begins in middle school. Is there bias in science when you're dealing with science? Is there bias when we're talking about social studies? I mean, bias permeates all aspects of our lives, right? She noticed that there might be a reason there was a bit of bias among the women that if they found a defective barrel, had to roll it uphill and pitch it over a cliff. So she decided to make there be a collection at the bottom of the hill. So if there was a barrel that was rejected, the ladies just had to roll it down the hill to this catch-all, and then they would come and pick it up. Guess what happened to the number of barrels that got rejected? And nobody had ever thought about bias. So we have Guinness to thank for our study of bias. Okay?
So part of the idea about the statistics is more than just a number and an addition, a subtraction, multiplication, division, derivatives, whatever. Statistics also involves detecting abnormalities in data sets and attributing those abnormalities to causes. So if you go into statistics, you can consider all kinds of fascinating questions about experimental design and how do the calculations account for that. And those are the kinds of things that you can begin discussing long before you can actually do the calculation by hand. And you can start doing the actual calculations on a calculator long before you really understand what's happening underlying those calculations.
So the book is full of lots of things. We wanted to give you an overview to show you the richness of using something like a trade book. One of the other cool stories that is in this trade book is one of my personal favorites, Florence Nightingale, because I guess she holds a special place in my heart since my mom was also a nurse. Do you know what we have to thank Florence Nightingale? Now, most of you all don't even think about Florence Nightingale as a statistician, do you?
You all know Florence Nightingale, right?
Okay. We got the nursing department, just like right over there. So, well, except now they're like over on the other side over there. They've moved. She worked on the war field. She was taking care of the wounded. They would run out of bandages. It was her job to go and tell them, we need more supplies. She was a female. They might listen, usually they didn't listen. So she had to devise a way to show them inventory to let them know they needed to be better prepared. Hence, we have her to thank for some of our graphs, like pie charts. So this is a great book for classrooms. You do not have to read every chapter in a book. These chapters stand alone, and they are quite wonderful. To end the one space, just to show you, you're holding a new TI-84 CE, which is the latest and greatest of the TI-84 line. You'll see in just a minute the wonderful resolution on the screen, its color and everything. This is what Sir Fisher did his preliminary calculations on back in the day. That was his calculator. It simply would calculate numbers into the millions, where he didn't have to do it by hand. That was his calculator. We've come a long way.
And we thank TI also because they shipped us these calculators to borrow, and then and they pay for the shipping, and then we package them all up and ship them back. So they will do that when you need to do that.
And in your classroom, I'm a T-cubed instructor. So in your classroom, if you would like to try out some TI technology, let me know, and I can help you work with that to get some potential loaners to try out. This is going to be as useful for science as for math. They have all the vernier probes. So those of you that teach science, there's all kinds of vernier probes you can do. There's sound probe. You can do temperature probe for crickets chirping. There's just a plethora of things that you can do. There's also health and occupation probes they're building in now. So let's move to the math.
So intensely into the math. The question we want to answer, and so now you're going to have to own this, so write it down. I know this is being a challenge, but what is a statistic? And what is a good example of a statistic? Come up with a brief answer to those two questions.
And I'm going to model for you a timed writing. I'm going to give you 72 seconds. So pencil to paper for 72 seconds.
What is a statistic, and what is a good example of a statistic?
Words, pictures, numbers.
This is not rhetorical. We're asking you to do this. Work with us here.
Okay. So what is a statistic? I saw some interesting answers. Anybody want to volunteer? And we're safe.
Yeah, the doors are shut. Nobody's going to know.
Yes, ma'am.
You have a measure of an approximate amount for a particular group or subject, and then my example would be like autism spectrum disorder 1 in 68 boys.
Very interesting, very good. So it's a measure, okay? Anybody else?
I just said statistics are numbers in context that tell a story.
Ooh, I like that definition. That could play with that one. Anybody
Did you have
else?
an example?
Yeah, my sample has 25% rotten apples.
There you go.
Data that represents a specific population's why, how,
Or what?
Whoa, now we're getting highfalutin. Now we got some of those mathy words in there, okay?
That's good.
No.
Event or phenomenon.
Interesting, an event or phenomenon. Interesting.
Example would be like a test score.
Okay. Now, as I was walking, I was actually going to call, but it was hard to find people that I could look over their shoulder and see what you were writing. In a classroom, you would kind of want to not start with your really mathy answer, but start with something that's less threatening so you don't shut down the rest of the class when you're questioning effectively. So the timed writing, let me talk to you about the timed writing for just a minute. I gave you 72 seconds. You want to give something weird. Do not give 30 seconds. Do not give a minute, because we all know what that is, and students will sit there and time themselves. Give something weird that they can't think about. Paper to pencil. You have to build stamina. So if you're in elementary school, you may want to start with something like 22 seconds, something weird. And then you start building up. Writing about math is different than writing about a creative writing story.
Writing about math is far more accountable. Ultimately, when you're writing about math, you are responsible for being accurate, and you can be creative and think out of the box, but you have to be responsible for providing content.
And notice when you were responding, I did 85% of my pre-assessment through the glossary part of my mathematician's notebook just with vocabulary. I made no judgment calls on anybody's answer. I didn't say, yes, that's right, or no, that's wrong. I maybe said that was interesting, or that's kind of a neat way to say that. But there were no judgment calls. So you need to develop and make that, because all of our coursework has course-specific vocabulary, right? And the English language is full of connotations. That, again, is one of the biggest challenges we have as teachers, is having these connotations. And in STEM, it is multiplied. Because in STEM, especially with the science and math, sometimes what we call something in math is not how you refer to it in science. And that's one of the things that is an issue unless you bring science and math teachers together and let them plan together so they can see how they talk about this common language, okay? So nobody said statistics is a branch of mathematics. That's good. That's how most of my stat students would start out defining statistics. Oh, it's a branch of mathematics. No, it's not. Math teachers usually teach it because we teach stuff with numbers in it. Statistics is the one course that every student in high school should have to take, because there's not a major on a college campus hardly that you can take that you don't have to have some statistics in anymore.
And in fact, The Lady Tasting Tea was written by David Salzberg to promote the idea that we no longer live in an algebra clockwork universe, and so we should be moving away from everybody taking algebra, trigonometry, and calculus, and be moving towards the introduction of math at all levels through statistics.
So we're going to start with middle school, okay? So we're now going to do some math. So be warned, we're now into math. If you're math phobic, hang with us. It's going to be painless. So we're going to start with univariate statistics. Dr. Martin, take it away.
So the top circle there, area and volume, that is using one number to represent multiple numbers. So we're very used to this. One way of looking at statistics is trying to represent, to pick a number or several numbers to represent a larger collection of numbers. It's to distill patterns and a central idea.
Which several of you commented on with your event, phenomenon, description. So you were in that area there.
So if you've got a closet that has an area, a size of 3 by 4, it has 12 square foot of area. The 12 is a loss of data, but it helps you decide things to do, like how much paint to buy. But so you could have a 3 by 4 closet or a 6 by 2 hallway, and that would give you, having both the 3 and the 4, or having the 6 and the 2, gives you more information. But more information isn't that helpful when you're in the store buying paint. You just need to cover a certain amount of area, and it doesn't matter what the shape is. So we replace the specific dimensions with a single number, 12, that you can go look on the paint can, and you can say, how much does this paint cover? How much space does this paint cover? So we're replacing multiple numbers, lists of numbers, with one number. That means we're involving one variable, and we're looking at the art and science of getting the right number so that we represent the collection of numbers.
So what are our basic univariate statistics? Take a gander. What do you think some of them are?
What words have come out
We're
of your
in
mouth?
middle school. We used to even do this in 4th and 5th grade in Tennessee. Measurements of central tendency. Ooh, there's a big word. Measurements of central tendency. Heard that before somewhere? What are those? The 3 M's. So as you're thinking about these, another thing that I love to do, whether I'm in kindergarten or on college campus, I love to use picture prompts, no matter what class I'm in, whatever I'm doing. So here's a picture. Write down at least one statistical question that you could ask students based upon that picture prompt. Again, putting you in the context of being a student, throwing something open that has a very low floor, but yet can have a very high ceiling, making it accessible to all.
State the question again, Tammy. How do you want them to think about that?
What statistical question might this picture prompt? Can you write one that you might ask your students?
Or if this is a graphic in a newspaper, what could you get from this graphic?
So who has a question? Anybody have a question yet?
Range.
How would that be a question?
What is the range?
What is the range? Okay. What is the difference between the highest and lowest values, which is how you calculate range? So you could ask that either way. Lower threshold, higher threshold. Just looking at it and saying, what is the greatest number up there? Anything else? There's the rub. Do those numbers have anything to do with the picture? If they do, what do you think about? If those numbers do relate to the picture, then what do you think? What are some things that might go through your mind? It's what?
Celsius or Fahrenheit.
Ooh, so we gave you naked numbers.
Nice.
Naked numbers, as you started the day saying, kind of meaningless, aren't they? Does it matter if they're Celsius or Fahrenheit?
Those are good questions. I
If
look
they're
at those bars
Fahrenheit-
on the back screen, and I can't see them as well because it's far away, and I wonder, are any two of those the same? Are they the same height?
If they're Fahrenheit, what should you be prepared for? And this is not rocket science.
If someone says it's -4 degrees, what do you think?
Fahrenheit.
I think I'm cold.
And I need to be prepared for cold, right?
I'm
Whether
cold.
that means bodily, whether it means in my house wrapping pipes or leaving water running or, leaving my car engine running, having a warming block on it, whatever, right?
So here's the idea. Those 6 numbers are the low temperatures in Minneapolis, and you're going to Minneapolis. How do you use those numbers to help you plan for your trip? Do you think, okay, the numbers range from -12 to 21? Do you think of the list of numbers? Do you think on average the temperature looks about, and what do you mean by on average? How do you pull an idea from a list of 6 numbers to help you pack a suitcase? That's a statistic.
Now, do you see how rich a prompt this is pedagogically? Sometimes we get so tied to our books where everything is so prescribed. We withdraw from the students the freedom of thinking out of the box. They come to college, they come to high school, they come to middle school, from wherever you want to place blame, where everything has been spoon-fed and prescribed. So here's this, do this, this, and this. You now sat in the place of a student. We threw up a picture, and we said, so, tell us about it. So what, who cares? Make up a question, but frame it in the context of something statistical, okay?
And let me tell you, you're going to care if you pack for Miami and you arrive in Minneapolis with temperatures like that.
Now, we're going to take a sidebar. You are actually playing today with the TI-84CE. This is the Inspire, which Tennessee actually had one of the first TLCs for Inspires over here at MTSU. We ran it, I think y'all ran it 2 different years. So there's a lot of Inspires floating around, but because we were going to be a park state, everybody decided to go back to the 84. I would never do data on anything but the Inspire, and I'm getting ready to show you why. This is about as random as you'll ever see. I literally went into the list and put in those numbers. And there's a dot plot. It's just randomly there, okay? So watch the screen. Nobody said, wow. Are y'all awake? What just happened? But the points actually moved. Would that now engage your students? This is a tool of investigation. It did put them in order. Why does that matter?
One of you asked the question. One of the statistics that you proposed was what was the range of data, right?
And somebody asked where the zero was. Well, there it is, right there. How does it give context? How has it given context?
Against a predetermined scale.
So we have placed them on a number line with which most of our students are familiar, right? If we're in social studies, this might be a timeline, right? If we're in science, it might be the timeline of a life cycle or something. But there is a context there which we can make some sense of. We see zero. Is zero in the middle? Does that bother anybody? Zero is always in the middle, right? Zero has to be in the middle. It's always in the middle. In our book, it's always in the middle. Not necessarily. What
So
if
we
wanted
went from a scattered list of numbers that were not representing anything to a number line plot from which you can draw the statistic of range. And if you look at where that plot was, you can also decide, okay, if I want to go towards the middle of the numbers to pack for my decision making about clothes, that gives me a kind of an idea about where to go.
So if I had a nickel for every time I've had a teacher ask me, why do we teach box plots, I could probably retire. That's a box plot, right? Yes, everybody's good with that? Box plot, box and whisker? So who cares? Why do we use box plots? What is the value of a box plot? We had our dot plot. It was nice, right? It was sitting on that number line. We could calculate our range. We saw the large and small. We found zero. That was nice. Then I went and messed it up because I said, make me a box plot. So why do we use a box plot? Variability. Oh, there's another highfalutin word. Y'all need to sit by her. She's our highfalutin person today. So what is variability? And that's just a good old English word that really, the connotation doesn't change from one place in the world to the stat math place in the world. So what does it mean if something varies, if there's variability? There's differences, right? In Tennessee, could that have been a typical day in March or April or even February in Tennessee there? You know, going from negative something to 20 something. If we're lucky, we might go to 60 one day. So variability. Why is variability important with data? Do we like variable data?
If you're trying to make one number represent a whole list of numbers, is it good to have a wide span of numbers when you're trying to pick one? It's harder to pick one number to be representative if you've got things stretched over a wide span.
And in today's world as consumers, we're all about statistics. You need to be able to educationally look at and informed decisions make about statistics. So what is this box plot doing for me? What can I now see that's very evident that I could not see with the dot plot?
The median.
The median. What is the median? Huh?
It's the center.
It's the center. So if I have my numbers, I just swap, go to the middle, and that's my median. And that's why that's one of the most missed questions on our old gateway. What is the median?
Do you want a number now?
Hmm?
Do you want a number now?
Well, okay, the median you said is about 3. We can actually see what it is in just a minute. But really, what is the median? We define the median, I mean, every teacher, if you polled 100 teachers in Tennessee, probably 99 of them would say it's the center. Is the median really the center? I have my numbers. If I went back to the slide that we had up there earlier, and I had those numbers, could I just plop to the middle and that's my median?
No,
Why?
because we have an even number of data.
Oh. So I could go between plop, 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 and whatever was here, I could then find the middle between those on the slide that we had originally. Why? Oh, does that matter? Why? Y'all have never had a teacher like me. They're going to love going back to you because you probably don't ask them why so much. It's all about the whys. So I have to have data in order before I can start looking at trends, right? I have to be able to make sense of it. And the way we make sense of numbers is to quantize them and put them in some sense of an order. Why am I the median? If I were to do my typical activity that I have, Dr. Martin has, you know, they've seen me in the math department, take my math class out of the hall and give them index cards with numbers on them, and we make a human dot plot. And then we figure out who's the median.
And what's the difference between median and midpoint?
Oh, you've changed subjects on us now, Dr. Martin. You brought in geometry. Where'd that come from? How dares you go do that?
Hey, it's math.
So let me ask you this. Here's our median, right? This is our median. See, y'all are close. It's 2.5, 2 and 5/10, 2 and 1/2. Y'all were really close. What's that left side? Left side of the box. What's this right here? And so it actually starts out at, its boundary is actually -8, right? So what does that mean that this is the lower quartile if I'm going from -8 to 2.5 for the median?
I don't think 2.5
Statistically,
is
what does
the
that
midpoint.
mean?
25% of the time, you're -8 and
So a
2.5
quarter of my
degrees.
data actually lives right there. So no matter what context and discipline you are looking at data in, if you don't understand what the median or quartile is telling you, then you cannot make sense of your data, no matter where you are. So it becomes really important. So what about over here? If -8 was my lower quartile, that's my upper quartile. Gosh, we're talking about quartiles, but that says 3. How does that work?
And why isn't that line in the middle? It's not very appealing. I want that line in the middle.
So what does that tell me? If the bottom quartile told me that a quarter of my data lives there, then what does the upper quartile tell me? The same thing, except it lives up here, right? Now, this is dissonance for the brain. This is why some of your students are struggling when they're looking at data in the context of whatever you teach them with data, because that should be in the middle and they should look the same. How can you say half of it when there's such a bigger box there? Why is that? Because what is the true definition of a median?
I know.
Only because she's been with me, beating teachers over the head doing this for so many times. I am a center of central tendency only by virtue of my location. That is the only reason I am the median, is because I happen to be centralized amongst all the data. There is just as much data on my right as there is on my left. That's the only reason I'm the median.
So it's not a midpoint.
So it's not a midpoint. Now, what about these whiskers? What do we talk about these whiskers? Oh, there's a whisker. There's 21. What do your students sometimes call those? That's a max, but sometimes they actually mistakenly refer to them as OU. It only took you 2 letters to get that word. Outliers. Statistically, is that an outlier? It's got to be more than that from the median, right? What happens if I move 21? Mary wants it in the middle. If I drag 21, is that going to change my median? It will. Anybody else want to guess that? Do you agree? So if I move 21, I move 21. Did the median change? Ooh. I'll move it some more.
This is a good example of a diagram that has replaced a different diagram, and you change the information you can get to.
I'm moving it some more. Oh, what just finally happened? Did you see when it moved? It moved because suddenly my location has changed. I have brought in that number, and somewhere now there's some overlap, and all of a sudden median changes. Median is affected only by introducing new data that will skew it one way or the other.
If you take another thermometer reading and plop it down into your list, then the median will move because you either popped it above the 50% data line or below, depending on where you did it.
And that's a really good, you want some out-of-the-box non-routine assessment questions, that's a really good assessment question. Give a value for a piece of data that would affect the mean, that would lower or affect the median, that would lower the median, or that would increase the median. And that really gets to your students' understanding of, do you know what a median is? So we have 2 other measures of central tendency. Do you remember the dot plot? If we go back and look at the dot plot just for a minute. Dot plot, plot type.
And hang with us a minute. We're going to
Is there
do
a
a couple
mode?
things and give you a break.
Is there a mode? How do you know there's not a mode? The Inspire is the only thing that will show you a mode. If there were a mode, you'd have stacked dots. And the mode is what?
The most common value.
So it is the one that recurs. We talked about that frequency thing. It is the one that has the highest frequency. Does everything have a mode? Obviously not. We call it amodal. Can it have more than one mode? It can be bimodal, trimodal, okay? Then we have the third one. Mean. What's a mean? What's an average? But you know that what you're going to tell me is how to get it. Most teachers jump in there and say, oh, you add them up and divide by how many there are. That's how you get the average. But what is an average? You never thought middle school math was going to be so deep, did you? This is what our 6th graders are having to learn with understanding now. Just to give you a sense of where we are right now. So if you're doing science, this is the level of statistics your students are supposed to have with sophistication now, so you can do data with your central tendencies in science, okay? So an average is that number that typifies or is typical for your set of data.
That's where we started this with the temperatures, right? We said we want one number to represent this collection of numbers, because we can deal with one number, we can't deal with 6. We need to make a decision.
So which measure is most affected by the outliers? The mode, the median, or the mean? Why? Because the mean is based upon a what? We actually don't do it justice. We call it the mean, but really it's the arithmetic mean. So that tells you why it gets affected the most, because if something is arithmetic, it was calculated by arithmetic. Okay? I am the median. Why? only because of my location. An outlier may or may not affect me. I'm a mode only because I happen to occur with the most frequency. So an outlier may or may not affect me. But you throw an outlier into a set of data and calculate the mean, it will automatically adjust the mean.